8.2 is testing the mean. So what we're going to do is, first off, test the population mean when we know our population standard deviation of sigma. This is exactly like what we did in 8.1. So I'm going to do a quick review with a problem just like 8.1. Again, you don't need to know any of the steps with your formulas. All you have to know is how to type things into the calculator. You do not need anything with the formula. So it's the exact same steps that we were following. So we're going to look at example 3 together. Sunspots have been observed for many centuries. Records of sunspots from ancient Persian and Chinese astronomers go back thousands of years. Some archaeologists think sunspot activity may somehow be related to prolonged periods of drought in the southwestern United States. Let X be a random variable representing the average number of sunspots observed in a 4-week period. A random sample of 40 such periods from the Spanish colonial times gave the following data. So that means our N is 40. Your sample mean is X bar equals 47. Previous studies of sunspot activity during this period indicated that your sigma is 35. It is thought that for thousands of years, the mean number of sunspots for a 4-week period was mu equals 41. Sunspot activity above this level may or may not be linked to gradual climate change. Do the data indicate that the mean sunspot activity during the Spanish colonial period was higher than 41? Use alpha equals 0.05. So we've got, on the next page, our list. It was hard for me to squeeze all of it in. So hopefully you can go back and forth. So they said our alpha was 0.05. Your null and your alternate hypothesis. Again, we're looking at 41. That's what it used to be, was 41. Now they want to know if the data indicate the mean sunspot activity during the Spanish colonial period was higher than 41. If we're higher than 41, they want greater than 41. So now we're going to go through, run our z-test just like we did. Our mu was 41. Now for our sigma, go back and read. It said sigma was 35. Look at your X bar. They tell us that's 47. Now for our N, we said that was 40. Then for our alternate, we have greater. So here's our list. We got our Z. So I have 1.08. My P. And then we're going to compare. It is greater. When it's greater, remember, you fail. So we failed to reject the null. So now we're going to write our sentence just like we were doing. So we all know how to start this. We were 5%. So again, 5%, there is not enough evidence to conclude, and then you're stating what we just found in the test, to conclude that the average sunspot activity during the Spanish colonial period was, hopefully I still have some space, yep, was higher than the, so there's not enough evidence to conclude that the average sunspot activity during the Spanish colonial period was higher than, let's just say, or 41, yeah, it was higher than 41. If you're trying to figure out what's right in your sentence, look at the question they're asking you. It says, do the data indicate that the mean sunspot activity during the Spanish colonial period was higher than 41? So all we're saying is your level of significance, not enough evidence to conclude that, and then you basically are just rewriting that last sentence. Now, the other way to test your mean is if we don't know the population standard deviation. So instead of sigma, we now have S. Remember, if you have S, you have to do a t-test. If you have sigma, we have a z-test. Again, if you have S, it has to be a t-test. If you have your sigma, it has to be a z-test. So we don't have to worry about any type of math as we go through this. No formulas. This is the main thing, your calculator. You need to know how to type it into your calculator. You use your t-test now. So we're going to go stat. We're going to go over to test, just like I said. Instead of a z-test, it's a t-test. It's pretty much all the same. Now you're just filling in all of your parts that are from your problem. So we're using the t-test for this because we have the sample, not the population. So for example 4, we've got this drug that is used to treat leukemia. The following data represent your remission times in weeks for a random sample of 21 patients using your drug. You have to find your X bar and your S. So that means we have to go through stat edit, type all of those numbers into L1, and find our 1var stats. So you must do that first before we can then find all of our other parts. So the rest it says, let X be a random variable representing the remission time in weeks for all patients using the drug. Assume the X distribution is mound-shaped and symmetric. Previously used drug treatment had a mean remission time of 12.5 weeks. Do the data indicate that the mean remission time using the drug is different from 12.5 weeks? Use your alpha. So I've got 0.01 for our alpha. Your null, it says, was 12.5. Now they're saying different. Whenever you see the word different, it's always doesn't equal. The rest, we're going to have to use our table to type all this in. So we need to go through then, hit your stat button. We want edit. If you've got numbers in L1, go up and clear them. Start typing it in. It's going to take me a while to type mine in, just as a heads up. Go back, double check, make sure you've typed everything in right. After you type it in, remember we do stat, go to calc, and you want one var stats. Your list needs to say L1. So make sure it says L1 if that pops up. Go down to calculate. So for our X bar then, we should have 17.1. And now we want S. S is, it looks like 9.99999. So if I round that, it's going to be a 10. Again, WebAssign will tell you how many decimal places they want when they go through it too. Okay, so now going through this, we're going to hit stat. We're going to go over to our test, and we want t-test. Now, if you have stats dark, they are going to go through and give you what your X bar, S, and your N are already, because they take it straight from your data that you just did in your L1. So all those numbers are there. If you would rather round it to what your X bar and your S are, you can. Do not have to. So for your mu then, we said 12.5. And we said that it doesn't equal. So our numbers should still be very close to each other. I get 2.11 when I round that. Looking at your p-value. Now again, depending on what numbers you use, it's going to be very close to 0.0480, might be a 0.047 something or 0.048 something, very, very close to it. So now we're comparing those. We are still greater, so again, we're going to fail to reject. So we failed to reject, so now we're going to write our sentence. We say there is not enough evidence to conclude, and then we finish it off. That the drug provides a different average remission time. Than the previous drug. So again, the exact same stuff as we were doing. So going to the next one, I want you to do this on your own and then come back with me. Now, if you notice for this one, you do not have to plug numbers into your L1 to find your X bar and your S because it's already given to you in the problem. So sometimes it will be given to you in the problem. Sometimes you will have to go through and use the L1 and your stat and your calculate to then figure out what those numbers are. So it just depends on what they want to give you in the problem and you go through it. So again, pause this and go through it on your own to see what you remember. Okay, so we should have answers for this one. Archaeologists become excited when they find an anomaly in discovered artifacts. The anomaly may or may not indicate a new trading region or a new method of craftsmanship. Suppose the lengths of projectile points or arrowheads at a certain archaeological site have a mean length of mu equals 2.6 centimeters. A random sample of 61 recently discovered projectile points in an adjacent cliff dwelling gave the sample mean x bar to be 2.92 centimeters, and the sample standard deviation is s equals 0.85, where x is a random variable that represents the lengths of all projectile points found at the adjacent cliff dwelling site. Do these data indicate that the mean length of projectile points in the adjacent cliff dwelling is longer than 2.6? Use 1% level of significance. So I got our alpha. We've got our null. So they said previously then it was 2.6. Now they want to know if they are longer than 2.6. So now they want us to find our t value. So we're going to go stat over to test. We want our t-test. So I'm going to go down to my mu, 2.6. Our x bar, they told us to be 2.92. And then our s, they said 0.85. For our n, we're looking at a sample of 61. So n is 61. And we are greater than. So go over to greater. And then go down to calculate. So here's our numbers. So I have 2.94 is my t. We've got a p of 0.0023. Now we're going to compare those. That is less than. So when it's less than, now we can reject the null. So it's the exact same sentence, but we don't write the not. So at the 1% level of significance, there is enough evidence to conclude that the average projectile point length at the adjacent cliff dwelling site is longer than 2.6 centimeters. So when we reject, we have almost the exact same sentence. You just don't write the not. It's everything else is the same. You don't write there is not enough evidence. Instead, we say there is enough evidence to conclude it. So again, 8.1, 8.2, very similar to each other. You have to figure out which one to use, because I won't necessarily tell you if it's going to be a t-test or a z-test. You have to know. So you know it has to be a z-test if you know sigma. You know it has to be a t-test if you know s. That's the main thing. If you need to write that down to remind yourself, write that down somewhere, because that will affect your answer if you don't choose the correct test as you go through this.